Okay, so if we are looking at sketching graphs, a quick recap on our rules before we look at an exam question. We've seen all these rules with a quadratic before in the junior cert. Okay, so I'm going to put a quadratic up here just to kind of allow us to think about some of those rules. Okay, so there's a quadratic. We can also think about them in terms of any other polynomial. So anything like a cubic, we could have a power of 7, okay, a power of 8, and so on. So the first thing is these rules, okay, so they're going to work for any polynomial. It's to do with the highest degree power. So here, when I'm saying a cubic, I could put in an x cubed, an x squared, an x, and a constant. I don't have to have each one of them though. It's only just to do with really the highest power that's there. So the degree is the highest power. Okay, so that's perfect. So here, my quadratic is of degree 2. Okay, what does that tell me if I'm looking at a graph? It tells me that the quadratic has one turning point. Okay, so there was one point there where it turned, and it has maximum 2 distinct, different roots. So distinct means different roots. It has maximum 2 different roots. Okay, if it didn't have 2 different roots, what would it have? Okay, so if there was a different quadratic there that didn't have 2 different roots, another option could be that it has 2 equal roots. So there, let's say that was 5. Okay, then the roots there are 2 equal roots, x equals 5 and x equals 5. So remember, if the root is a turning point, okay, if it crosses the x-axis at its turning point, then that root is counted for twice. Okay, and we done that when we done our discriminants. So if the b squared minus 4ac was equal to 0, then the 2 roots were going to be real, but they were going to be equal. Okay, the other option there, okay, so it's maximum 2 different roots. So here we only have one root that's repeated. The other option is that it has no real roots. Okay, so that is still another option. So that's why we're saying max 2. So if the quadratic didn't cross the x-axis at all, okay, then it doesn't have any real roots. So it's maximum 2 real roots, and it has one turning point. Okay, 1 because it's 1 less than whatever the squared is. So if we think of a cubic, it has a power of 3, which means it has 2 turning points and max 3 different roots. Okay, so that's the first one, our degree. If it is of even degree, look at our quadratic. Okay, this is our positive quadratic, okay, because it was a positive leading coefficient, so it was a smiley face quadratic. Okay, both arms face up. If it was a negative quadratic, okay, so let's say it was negative instead. So if it was a negative here, then it would have been a sad face quadratic, and we would have had both arms facing downwards. Okay, so either both arms face up or both arms face down for a quadratic, because its power or its degree is even. If it was an odd degree, like in a cubic, then either both arms face left and right, or both arms, down and up, or both arms face up and down. So they're both opposite to each other. Okay, so because it's an odd degree there, we have one going downwards and one going upwards. And we can actually see how, the same way with our quadratic, okay, in the quadratic, if it was a positive leading coefficient at the start of the quadratic, okay, so a positive leading coefficient, so a plus, then the right arm of that had to finish by facing upwards. Okay, and it was just the fact that it was even that it meant that the other one also is upwards. Okay, so that being positive tells me about the right arm. Okay, so if the leading coefficient there was negative instead, then the right arm would have to face downwards. Okay, if it's if it's an odd degree, okay, it's the exact same rule. Okay, it's purely to do with the leading coefficient. So in this one, the x cubed. Okay, here it's a positive leading coefficient on that x cubed. So I'm actually into here number 2. Okay, the leading coefficient is the number in front of the term with the highest power. So if the leading coefficient is positive, then the right arm is facing upwards. Okay, and then because it's an odd degree, the other one is going to have to go downwards. If that leading coefficient was negative, okay, so the number in front of the highest power was negative, then the right arm has to face downwards. Okay, and then again, because it's odd, it means the other side will be the opposite way, so it'll be facing upwards. Okay, so we went through those in class, but just to kind of recap over them. Likewise, the leading coefficient, if there's a number in front of this x cubed or this x squared, it can just change how narrow the graph is. Okay, so if, for example, there was a 2 in front of this, okay, instead of maybe looking like this, it would instead be quite narrow like that. Okay, so it kind of change how narrow the graph looks. Okay, or likewise, it can make it less narrow. So, sorry here. So if it's less narrow, more wide. Okay, multiplicity. Okay, so in roots, something coming up twice. Okay, so something coming up more than once, multiple times, happens when a root occurs multiple times. Okay, so here is our example. Okay, where it's a turning point is a root. Okay, if that's something like 2, then that is there twice. So multiplicity happens when one root occurs multiple times. So that happens if the turning point or the graph touches the x-axis but doesn't cross it. Okay, if it crosses the x-axis, then it's an odd multiplicity, so it probably only comes up once. Okay, so loads of stuff kind of flew through there. Okay, so we're going to go through an exam question looking at all of this. And here's our exam question. Okay, so I'm going to just zoom past that. So it says the profit from shed type H. Okay, so here we go. So here's some algebra coming up in a different topic. So it's talking about profits. Okay, and talking about profits in terms of functions. Okay, so it's talking about profits, functions, okay, but we are really just coming back to our algebra that we know. So the profit from shed type H can be modelled by a different function, h of x. So obviously earlier on in the question there was a different function, where x is the number of sheds sold and h of x is the profit in euro. Okay, that is all essentially irrelevant to me. I don't need to highlight anything. The diagram below, not to scale, shows the graph of y equals h of x for some x element of or. The coordinates of 4 points are given. Okay, perfect. Really, all this information is all relevant in just this one graph. Okay, and I've been given my 4 points. Okay, use this information to write out h of x. So write the function in this form. Okay, so we are writing a function and we have been given different roots. Okay, my roots are all of the places where it crosses the x-axis. So from this, I can say that my roots, everywhere that it crosses the x-axis, so I have minus 21 as a value for x. I have x is 12, and my last root, x, is 47. Okay, so x is 47. Okay, so I'm just going to draw it all on here underneath. So I'm going to ignore everything at the top so that I just have space to write it all out clearly. Okay, so x is minus 21. They're my roots. X is 12. They're the places it cuts the x-axis. And what I'm going to do after this is I'm going to use my factor theorem. I'm going to use those to find my factors. Okay, so if x is minus 21, that means that x plus 21 is a factor. X minus 12 is equal to 0. Okay, I'm going to write all of them out equal to 0. Okay, and now I have loads of things multiplied or I have loads of things that are equal to 0. I'm trying to find the function. Okay, bearing in mind, look, they gave me a function here. Okay, and if I had, like, let's say they said to me, write f of x equals x squared plus 5x plus 6. Write that as x plus a times x plus b. Okay, you'd know I just have to write down the factors. Okay, I just need to write down the factors. That's what they've told me here. They've said write the function as a, so something in front of all the factors. Okay, all the things multiplying together to give me the function. So it's actually a really nice question. It's literally saying, okay, well, what are all the factors of this? Okay, so I'm literally just writing out all the factors. So I have now got that h of x is a times, and I have all of the factors here. So it's x plus 21. Okay, so remember the signs always change in our factor theorem. Going from roots to factors, the signs of the numbers always change. Okay, x minus 12 is another factor and x minus 47 is another factor. Okay, so we have literally there gotten almost the full question. I've filled in for B, for C and for D. Okay, so I have literally filled in all of this except for A. Okay, it wants A to be a real number as well. But I have filled in for B as a real number, I filled in for C as a real number, and I filled in for D as a real number. So I just need to fill in for A now. And I have to figure out how to do that. Okay, so if you've gone over your functions recently, then this would be a nice question. Okay, if I had something like f of x is something like, I don't know, 2x plus 1. Okay, and then let's say I had another point on the graph. Okay, because if I look here at how to get a, the only thing that I can see is I'm working with functions and there is a point on the graph I haven't used. Okay, so there's a point on the graph that I haven't used yet, and it's this point here. Okay, I don't know how to use that. So I'm going to go back and think about my everyday functions, and I'm going to think, if I had a random point on a graph, okay, how could I use it? Or even more specifically, if I had a point with a 0 as the x value, how could I use it? Okay, so if I have an x value, something like 0, or I can even do something like 2, okay, what would the matching y value be? Remember, f of x is the same as y. Okay, so this is essentially y, not the x, the f of x altogether. Okay, so f of x is all y. So how could I figure out the matching y? Well, I could sub in 2 for x here. So it'd be 2 times 2 is 4 plus 1 is 5. Okay, so it'd be 2 and 5. Because if I sub in for my y value and my x values, they should work out as equal sides. So if I sub in for y here, I'll get 5. And that's going to be equal to 2 by my x value, 2, plus 1. Both sides should end up equal to each other. Okay, so I can remember that from when I done my functions. So how could I use that to somehow apply this point here? Okay, well, I'm going to do exactly the same thing. I've been given an x value of 0 and a y value, a matching y value of minus 1316. Okay, so I can fill in for y, or h of x, as minus 1316. And that is equal to a times. So my x value there was 0. Okay, so 0 plus 21 times 0 minus 12 times 0 minus 47. Okay, so look at my equation now. Is it in the form they want? No. But is this getting me towards finding A? Yes. Because A is my only unknown now. Okay, so this is actually putting me in a really good position towards finding A. Okay, I'm not even focusing on the question and the functions and all that. I have literally just noticed that A by 21, by minus 12, by minus 47 is minus 1,316. So I can find A. Okay, so I'm going to do my calculator. 21 by minus 12 by minus 47. Okay, and I'm going to get that minus 1,316 is 11,844 A. Okay, so get A by dividing by what's multiplying it, so the 11844, and also divide this side by the same thing. So 316. Okay, so I'll get minus 1/9 is A. Okay, so is that my question finished? No. Okay, but I have A. The reason why my question wasn't finished up here is because I hadn't filled in A. Okay, but that is how the form should look. So I actually am going to fill all this in, or rewrite it all out, but just filling in A. Okay, so I'm going to write out, so it's going to be h of x is equal to, so now A is minus 1/9 times x plus 21 times x minus 12 times x minus 47. And that is my answer. Okay, does it make sense that it's a minus as the leading coefficient? Yeah, okay, so when I multiply all these x's, an x by another x, and get an x cubed, it makes sense that there's a minus 1/9 gonna multiply them, so that it's a minus value for an x cubed, because the right arm is facing downwards. Okay, it's gonna make sense that it's an x cubed because one, they told me in the question it was going to be an x by an x by an x. Okay, there's also 3 roots which matches an x cubed, 2 turning points which matches an x cubed. Okay, so we have my final answer there.